Okay, we're going to go ahead and take a look at lesson 1A.8 today. We're talking about segment and angle proofs. Trying to get my light set up here a little bit better. Well, when we are looking at proofs again in this lesson, we're going to be talking first about using some new terminology. And these words here are the words postulates. Okay, I'm going to tell you what a postulate is. Now, you don't have to write this down, but I do want you to understand what a postulate is. A postulate, or sometimes it's called an axiom, I'm not really going to call that again this year, but that's what it is. It's a statement that is accepted as true without needing to be proven, without proof. Okay, I don't have to prove this. And we'll talk in class about where that word comes from a little bit, but here are some basic postulates we've actually used already. You just may not have realized it. Here's the first one. Okay, segment addition postulate. We talked about segment addition before, and that's just the idea that part plus part equals whole. Okay, and there's a formal way of writing that. If we have B is between points A and C, then AB plus BC equals AC. Okay, and so that's kind of going to look like this. We've got A and C and B, then AB plus BC equals AC, all right? And that's our segment addition postulate. Now, there is something else I want you to write down. And this isn't a postulate, it's what we would call a definition, but we can use this in certain proofs also. The definition of midpoint is either part times 2 equals whole, or part equals part. Okay, and those are, anytime we set up an equation like this, because of the word midpoint, we're going to give the reason definition of midpoint. So that goes with our segment addition postulate. But we also have postulates from angles. Now, we've talked about these as well. That's just the angle addition postulate. Which is part plus part equals whole for angles. Okay, it looks like this. Okay, if we've got some point in the interior of an angle, let's call that point X, then the measure of angle ABX plus the measure of angle XBC equals the measure of angle ABC. Okay, and we've done that a lot. But we do have another term I want us to put here, another definition, not a postulate, but a definition we want to use. Okay, and that's the definition of the word bisect. Okay, and that's again, 2 times part equals whole or part equals part for angles. Make sure you have those written down. Other than that, in this lesson, we're just using content from previous lessons. We are going to build and solve equations again, but using some of these initial reasons after our given to help set up our equations. So we're going to try an example or two together. And this video probably won't cover every example. We'll do some of them in class, but I want us to take a look at how to set up some proofs again. Okay, so as we look at example 1, we've got our given information that point B is between A and C, and then they give you these lengths. Okay, so our first statement is going to be that given information, and this part of it we're actually not going to write down. We're just going to draw a picture, since they don't give me one. B is between A and C. That takes care of that, but I do want to write the rest as my given. There really shouldn't be segment lines there, because we're saying lengths are equal. So AB equals 3x minus 2. BC equals 2x plus 14. And AC equals 3x plus 42. Okay, that is all given to me, and I'm kind of running out of room here, so I'll just write given right here. And then I do want to go ahead and fill that into my diagram. Okay, that's not part of the proof, but it's going to help me set this up so that I know what the parts and the whole thing are. So AB is 3x minus 2. BC is 2x plus 14. And AC, the entire thing, is 3x plus 42. So in a proof, the next thing in a problem that we were working this out as, the next thing we would do is go ahead and fill in our equation. However, we're going to take an extra step in our proof. The first thing I want to do is to write this kind of equation. And in fact, I'm going to write this exact one because I'm using those points. Because I have to have an equation to plug into. So I'm going to say AB plus BC equals AC. I'm actually going to write out those parts in that form. And this, again, is a part plus part equals whole because of the segment addition postulate. So we're going to abbreviate that as seg add post for postulate. All right? Now, if you wrote part plus part equals whole, that would probably be okay if you can't remember this, but let's try and remember that that becomes segment addition postulate as the reason for your proof. Now I can replace AB with 3x minus 2 and replace BC with 2x plus 14 and replace AC with 3x plus 42. And when I replace things equal to other expressions, that is substitution, S-U-B-S-T period. Now this becomes a problem like we did in the previous lesson where we're just solving the equation, showing the reasons for each step. So the next step is going to be to combine our like terms. 3x plus 2x becomes 5x, and minus 2 plus 14 becomes plus 12. Everything else just gets rewritten. Now, since all I did was combine like terms, I just simplified that. So we're just going to say simplify. And actually, over here, this might be a good little note to make. When we combine like terms, we're just simplifying. So this would be my reason in a proof. Okay, if I combine like terms, just write simplify. The same is true if we just add things together. If we just condense or multiply on one side of the equation, we're just going to write simplify. All right, so let's keep going in our equation. Next step down. The first thing I would like to do, and you can do this a little bit differently on your own, but I'm going to put the x's on one side. So that means I'm going to cancel the 3x by doing minus 3x to both sides. It cancels there. 5x minus 3x is 2x. So I bring everything else down. And since all I did was subtract the 3x from both sides, my reason is the subtraction, S-U-B-T-R period, P-O-E. Okay. If I'm going too fast, you are welcome to pause the video to copy anything down. Otherwise, just keep following along. The next thing we would do is subtract 12 from both sides. Minus 12 here cancels. 42 minus 12 is 30. Same reason. Subtraction, POE. Then we would divide by 2. Okay. So when I divide by 2 on both sides, x is just 15. And that's the division property of equality. Now, it looks like we're done, but remember, I want to prove something. I'm proving that BC is 44. So now we have to take what we would have and plug back into our BC equation. So we're actually going to write this like this. We're going to write BC equals, but instead of 2x plus 14, I'm going to plug in 15 for x. And since I took a previous equation in my proof and I substituted a value equal to x into that equation, that is substitution. And now all we're going to have to do is simplify this. Final step is what BC would actually equal, and this is where we do our math to double check. 2 times 15 is 30. 30 plus 14 is in fact 44, which is what I was trying to prove. And remember I said when we just combine things on one side, we do our math, we do our PEMDAS, we're just simplifying. So that's my reason. Okay? All right, and so that's how we complete, it's a little bit longer, but we complete a proof using segment addition, okay, using one of our segment addition facts. So we're going to look at number 2 together. I'm actually going to help you get started with number 2, and then I'm going to have you pause the video so you can do some more of this on your own. Okay, we are going to draw a picture for this first part again, but then we're going to write the rest of it in our given. Okay, so I'm going to draw an angle ABC. Okay, it's not drawn to scale because I'm supposed to prove angle ABC is 136 degrees, which would be much bigger than this. But we're just going to draw it in relative terms so we can get a picture here. All right, it doesn't have to go through the middle. It does, I'm sorry, we're told that it bisects. Very, very close to a mistake on my part. But these are congruent, so I want X to be right here, creating a congruent angles here and here. Okay. And so we're going to use that diagram in a minute, but the first thing we're going to do for our proof is write down the rest of our given, exactly as it's given to us. Measure of angle ABX is 3x plus 23. Measure of angle CBX is 2x plus 38. And that's all we are given. Okay? From that given information, I need to be able to set up and build an equation. Well, since this is a bisected angle, since this is an angle bisector, okay, our definition of bisect, remember, tells us that when I am using two different expressions for the parts, part equals part. And that's what I have. ABX is one part, and CBX is the other part. So these parts must equal each other. So that's what I'm going to say. I'm going to say the measure of angle ABX equals the measure of angle CBX, okay, because part equals part, which is from our definition of a bisector. And so that's what I use as my reason. Definition of bisect. Okay, we're defining that word to tell me what equation I can write. So now we can start to build our proof. Since I have an expression for this part and I have an expression for this part, that's what's going to be written next. I'm going to replace ABX with this expression. 3x plus 23 must equal 2x plus 38. Okay? And again, our reason here is that we substituted equal expressions in for these geometry names. So it's just substitution. All right. Now I want you to take it from here. I want you to take the next few steps where we solve for x. Okay? You should be able to do this in another 2 steps, I believe, to solve for x. All right? Just another 2 steps. I'm going to pause the video recording and let you have time to do that. You should pause so you can give yourself time. And then we'll check answers together. Okay, this is what we should have. Okay, we should get x is 15. Again, that's not what we're trying to prove, but that is what we are getting for x. Because when I take this equation, the first thing I chose to do is subtract 2x from both sides, giving me x plus 23 equals 38. Then I will subtract 23 from both sides, giving me x is 15. Now to finish the proof though, we want to show that the measure of angle ABC is 136. All right? Now, this is a little bit tricky because I haven't said the measure of angle ABC in an exact expression. So I need to actually take a step to say this. I need to say the measure of angle ABX plus the measure of angle CBX equals the measure of angle ABC. All right? And our reason for that is angle addition postulate, because that's our part plus part equals whole, but we need to say that. Angle addition postulate. All right? we're going to keep going a little bit. Now we can substitute in for what I have. We're going to do a bunch of substitutions at once, all right? Now, this is the one chance when we can actually flip this around a little bit and just say the measure of angle ABC then is equal to 3 times 15 plus 23 plus 2 times 15 plus 38. Okay, this expression comes from measure of ABX. This expression comes from CBX, and we're just plugging in 15. Okay, all we did was substitute there. And now all we have to do is simplify all this together. Okay, when I do this entirely, 3 times 15 plus 23 is 68. 2 times 15 plus 38 is also 68. 68 plus 68 is 136. You can use your calculator to show that, but that's the number we should get. And that is what we were trying to prove. Put my degree symbol so it matches. And all we did there was simplify. All that work in one step is just simplifying. And so that finishes that proof. Okay, we've got a couple more examples that we will look at in class. Okay, as we go through this, if you have any questions, make sure you stop and ask. If you need to go back and replay any of the video, do that. But make sure you have these notes ready to go for class.